Okay, I hope everybody had a good morning tea, and thanks for coming back for the second session today. I'd like us to welcome Jim Lloyd from Clayfield College in Brisbane, where he's the coordinator of learning innovation and a passionate teacher of IT and mathematics. And so he's here today to speak to us about the use of Python and Pygame in senior IT.
Thank you. Thank you very much, Nick. Yes, well. On that note, I'm out now. Thank you very much for having me. Yes, as Nick says, I'm from Brisbane. We have winter in Brisbane too. It's not exactly the same as Melbourne winter, but no, it's fine. Just a little bit of banter to lighten the mood. Yes, thank you very much for having me. Basically, I'm from Clayfield College, as it says on the screen. We are pre-prep to year 12 college, so we have co-ed to year 6, and then from year 7 to 12, all girls. So pretty much around Brisbane, we're known as a girls' school, but we do have co-ed to year 6. I teach primarily 7 to 12, sometimes pick up a year 6 robotics class or something like that, but most of my work is in senior. So just wanted to talk today a little bit just about my own personal reflections on using Pygame for our senior IT class. And just my rundown is going to be, I'll talk a little bit about how we do things in Queensland, not a million miles away from other states, but just to give you a bit of context as to how we do it, the makeup of our subject areas and how I've approached the assessment tasks. And I'm going to show you some samples that the girls actually made and talk a little bit about how I assess them as well. So you may or may not be aware, Queensland senior assessment is changing. We had what's called the OP system, which is very distinct from HSC for tertiary entrance. But at the moment, we currently have our 2 main senior IT subjects. So we have IPT and ITS. Now, IPT is more your sort of guts processing, databases, systems, that kind of stuff. And ITS is a bit broader in its scope. So in some ways, that's good. But in some ways, it's difficult to define, particularly as we're moving to external assessment. It's going to be a bit tricky to actually manipulate. So to that end, both those subjects are sort of merging into something called digital solutions, which the first release will be next month, hoping to be fully implemented by 2019, but we'll see what our beloved Queensland government decide to do with that deadlines. So really, we're in an interesting time in Queensland in senior IT. We're sort of in a bit of flux because we want to prepare for digital solutions, but we want to maintain some of that good stuff that we've got in ITS, particularly in the girls' school. We want to maintain some of the design, multimedia aspects, while still getting the guts of the good coding happening as well. So it's an interesting time, in short. So the subject that I teach in senior IT, 11 and 12, is ITS, Information Tech Systems. The way we set up is 11 is formative, year 12 is summative. And as I mentioned, it's quite broad in its scope, so a lot of schools implement it in different ways. So some schools will actually focus pretty much on networks, nothing else but networks. Whereas you can go through UX, web programming, you can see up there as well. So what we do at Clayfield is we try and find a really nice balance, lots of web stuff, but also an element of the design process as well. And programming sort of threaded through all of that. And I think it works. The main assessment types we have in the ITS syllabus are, as you can see on the screen, supervised written basically means an exam. Extended response is generally maybe a multimodal or a video research report they've done, something like that. The main 2 we'll look at today, I'll tell you about, is a practical exercise, and I'll touch on the supervised written as well. But the big beast kind of things they do are called projects. But the smaller scale ones are practical exercises, and that's what I've done with Pygame. So the projects are typically, what we do are sort of websites or web presences, so we're doing responsive websites, app versions of the site, and practical exercises, what we call learning objects or games typically. So practical exercises are generally smaller scale projects, but they don't require an evaluation component. So they kind of do the design, the development, and then they stop, which is a little bit odd. But in previous years, we've used learning objects as a focus so that it basically gives the students a good parameters in which to work. Now previously, for the last 4 years or so, we've used Flash and ActionScript 3. I don't know if anyone's too familiar with Flash and ActionScript 3. And it has some very good points. It has some very not so good points. So yeah, historically and anecdotally, probably more fidgety, more unforgiving, more errors, prone to a lot of problems, and a very steep learning curve. So if the girls are coming into year 11 to do ITS and they haven't done in year 10 or 9 as elective subjects, they're kind of going to find that learning curve much steeper. And even for me, so many years before I came to Clayfield, I'd done ActionScript 2, but then ActionScript 3 was different enough that it was quite a learning curve for me also. And so it got me thinking, and also Flash is sort of being, shipped out, not shipped out, that's not the right word. Phased out is a better word. So many of my colleagues are switching to HTML5 as a way to sort of get around that, but still maintain that interactivity. We use HTML5 and jQuery for mobile app development, which is our application of that. But because I'm a big child, I like games. And I like getting the kids to actually design and create games, because I think using that situation, that context, provides a really rich context for the kids to actually implement the DDE cycle, design, develop, evaluate. And a lot of good comes from it. Plus, when I'm marking, I get to play games, so that's pretty good. It goes without, well, I need to mention my very understanding, supportive head of department, who basically gives me enough slack that I can say, hey, I want to do this crazy thing with Pygame. Can I please? Is it, yeah, as long as it matches the criteria, that's fine, off you go. Don't bother me, all right? So that has been extremely beneficial. And I hope he's watching. All right, so I basically went to my HOD and said, can I do Pygame, please, instead of Flash? And he went, yeah, okay, go on. So the task was, I gave the girls the following task: to design and develop a prototype arcade-style game with an educational purpose. Now, I chose those words very carefully. Prototype, because that puts a quality constraint on what they need to do in a short space of time, so they're not flipping out trying to make the next AAA title. Arcade style, so it's kind of simple in its functionality, and for an educational purpose. Now, for me, giving them that purpose is crucial because it gives them an audience and a clear goal as to what they're actually going to create. So rather than just making a game, who is this for? And then they've got to worry about, oh, should I make it for adults, for kids, for teenagers, whoever. But if it's an educational purpose, then that gives them fixed parameters. I give them a list of minimum inclusions, so it's got to have this sort of code element, and it's got to be done in this formatting, and you've got to have a while loop, you've got to have an if loop, you've got to have whatever. And a time constraint, obviously. So the practical exercise is generally about 3 weeks, 3 or 4 weeks, whereas a project can extend out to about 6 or 7 weeks. So to that end, this was the approach. So the first thing the girls did was identify their target audience and research the basic designs. So in their target audience, they'd pick an educational topic and they would run with it. So some of them, it might be healthy eating or whatever it might be. And then they'd use that as their basis. We start off with the procedural coding. So just sort of stepping through it, doing it the hard way, doing it the long way, as it's kind of a bit more intuitive, and then slowly moving into object-oriented sort of approach, ever so slowly, because again, it's only 3 weeks. And obviously the Pygame setup, I don't know if anyone here has used Pygame, but trying to install it on BYOT can be fun. Yeah. Well, I'm being sarcastic, obviously. It introduces time constraints. But we got there eventually. So if you're going to use this, I would say allow a bit of time before you start to actually get it all set up. There was asset creation. So I'd said in the description that it was a prototype. So they could just use basic shapes, just use the draw rect functions in Pygame to just make little squares that knock into each other. But they wanted to actually add their own graphics and chuck them in. So that was sort of a bit of an extension, but they all did it because they all kind of compete against each other. Ongoing testing, very important in the way we approach. And obviously just trying to teach them good coding practice as they go along. So commenting code, taking care of the white space and refactoring code, that kind of stuff as we go along. So some of the resources that we used include the Pygame website, one of the most ugly websites I've ever seen in my life, but has plenty of good reference material there. So if they're trying to find something, how do I draw that rectangle again? It's all there. It's pretty descriptive. So it was very helpful. It was helpful for me as well because I had to skill up a bit to get ahead of them just to know what we were doing. This website resource is really good, Invent with Python. I don't know if you guys have seen that. There's a bunch of free ebooks, PDF, and they're really good. They're really great. I use them for younger grades as well, as we're sort of just dabbling in Python, nothing formally assessed, but year 8, year 9 kind of stuff. They can make just basic, in the idle, just basic games and little generators and things, which is really cool. So that's Invent with Python. I think it's .com or .org, is it? Yeah. But check it out. This guy is on YouTube. His YouTube address is SentDex, which you can see on the right-hand side of the screen here. But he's got a bunch of lessons under a different channel, just to confuse you, the New Boston. So if you look for Pygame under the New Boston, he's done a whole course of making a little race car game, which is really cool. And the way he does things are slightly different to the way I would do things, but that's also good to show the girls that there's, well, the students, that there's more than one approach to achieving a task in Python and in Pygame, which I think is really cool. And then you say, well, what's the benefits this way over this way? And then learning happens, and that's why we're here. At Clayfield, we have the Office 365 suite, which is really helpful. So we've got the video channel on there, and I make my own flip videos because I'm into flip learning. And what we do is a division of flipping, which is called in-flip. So basically, the girls would come into class, and they can watch that video in class. The way our timetable is set up, that's doable because we have 1 hour and 15 long lessons. And the software I use for that is Screencast-O-Matic, which is a beautiful name. I love that. And yeah, just upload that to the 365 video channel. They can get it through the 365 online, so they can do it at home. They can do it on the BYOT, device independent, doesn't matter. But you could use YouTube or something similar. Okay, now I'm going to show you the results. These are a little video of the games that the girls came up with. It's not going to play in full screen mode, so I'm going to have to be really unprofessional and drop out into this. Is that going to work? Are you going to play? This was by Georgia, and she has a hamster called Oreo, so she made a game for it. No, it's not going to work, sorry. I'll just quickly show you in this one. It plays in this mode, but not the other one. This is really helpful. So, basic left-right control, I suppose Space Invaders kind of style. You've got things randomly generating within a range along the top. It's what's called blitting in Pygame, which is actually just updating, printing that graphic to the screen every update loop. This is one by Steph, and that's Go Bananas. Very similar. Plays a little bit smoother. Yeah, not too much to it, but as I say, very simple kind of scope. Yeah, and it's a maze game as well by Molly, but I've exploited a cheat you'll be able to see in a second. There we go, yes. And then that presents another challenge, like how do you prevent cheating, or how do you code your own cheating in so that you can skip through your levels? Which I think in the early days of video game programming, that's why there were cheats, so the developers could just jump to level 10 and test it. I could be wrong. And yeah, so there we go. I'm a courageous little black square going in on my merry way. Yeah. Okay, so that's a maze game. Then there was this one, which was sort of mouse controlled as well. Yeah. A little bit incomplete, that one. But we got the idea. So it was kind of, she was experimenting with getting, yeah, just getting mouse control, which was unique for the group. And then this one was really cute. This was a little, like a skill tester almost. So you're the penguin, up and down arrows. You've got to get the fish, but avoid the jellyfish. And then when the hook actually collides with the sprites, yeah, you get points and points off. And that was quite a fun little one to help develop. Cool, all right, there it is. And a very cute little game over screen. So the general idea was, I won't play that one, that's just scrolling through the general code where you can see what they did well and what they did not so nicely. But the general idea was they had 3 game states, so they had a menu screen, game over screen. And working on those 3 basic parameters, they were able to sort of jump between the 3. If they wanted to create an extra level or some kind of bonus stage, they could. So there's a little capacity for extension, but again, it was only 3 weeks. So trying to compact this all down fairly neatly. So let me just jump back into preview mode. How am I going for time, by the way? Am I going all right? Okay, 10, cool. All right, I don't think I'll need that long, but cool. All right, so assessing these people, my students. Practical exercises overall were very functional. Because they were coding this all from the ground up, I was quite impressed with what they came up with, and they worked really hard on it as well. And there were plenty of issues. It was a learning curve for all of us. I keep saying learning curve, sorry about that. So there were things that they were trying to do that I wasn't quite sure how to do, so I'd go back to my resources, see if I could figure it out, and if I couldn't figure it out, we'd find some kind of compromise. Because again, they were keen to impress and do their best, which sometimes meant that they were sort of reaching beyond their capabilities within the constraints. Coding was generally sound. I'll talk a little bit about my own reflections on it later, but generally it was pretty good. Documentation was a bit to be honest. As is the way with a lot of technology subjects, in my experience, the kids want to just jump in, make it. Okay, why did I get a C? What's going on? This works. Where's your documentation? Oh, I don't know. Oh, I better design it after I make it. Is generally the way they work. I love the way their brains work. It was very difficult to sort of find the spread between them because the quality across the board was pretty similar. I'm not going to say it was fantastic, but it was good. But there wasn't too much to separate them. So what did I do? I gave them an exam, and they loved me for that. So the supervised written is just the written exam in 11 and 12. And this was done on the computer under direct supervision. So it was exam style, so a series of multiple choice ones, just on Python generally, and then some Pygame specific questions as well, with a few open-ended kind of questions just to balance it out. And they still forgave me. That's my class at their formal. There's only 5 of them, by the way. Very nice small class. So we still get along pretty well, even though I gave them a big, dirty exam. So, general reflections on using Pygame. Well, the pros of it was Python 3, I just love it. I really just love it. It just feels good. That's how I explain it to other people. And they say, why not JavaScript? Why not Python? Python just feels good to actually make and write it. There is no shortage of resources and tutorials, so for educational purposes, that's great. If you can get the kids to actually take the initiative to go, oh, I want to do this, how do I find out? Rather than going, oh, so what do I do? Actually go YouTube, find that CentDex guy, find the web resources. There's just heaps of stuff. Cross-platform for BYOT, oh, wow, it's the best. Because all the girls want lovely shiny Macs and all our stuff is Windows, that's kind of fun. But yeah, it's just perfect for that as well. And it's free. It's always good. Cons, installing Pygame was a pain in the butt, I won't lie. But we got there in the end, so it's not that big a deal. Because I'd look online and find how do you install Pygame, and there'd be 4 different ways of doing it, and only one of them worked. So yes, that was fun. Time was a bit of a constraint. It did mean, from a coding point of view, that I wasn't able to give them enough instruction on functions or classes, you know, as they would need to sort of know professionally. But it was okay for a little sort of introduction, I think. What would I do in future? I would consider that Python will work very well as a language of choice in digital solutions. Currently, we are probably going to favour JavaScript a bit more over Python, but it's really between those two. There's no reason why we can't do a bit of both, in my opinion. But in the first instance, I think JavaScript will work pretty well, but I'm going to try and plug as much Python in as I can. Yeah, so looking across platform options, again, JavaScript will work pretty well, but I like Python. It feels nice. I like it. As I say, yep. So for Pygame specifically, I wish if I had more time, maybe extending it back to like a year 10, doing a bit of Python, getting it set up there, exposure to object-oriented using classes, accessors, mutators, and really exploring the full range of Pygame elements, because there was some other stuff that we didn't get time to touch on. We sort of got the graphics in, we got the collisions happening, scores, timers, but there's a range of other stuff that we could do. Okay, well, that's it from me, everybody. Thank you so much for listening. If you would like to follow me on Twitter, that's my Twitter. That's sort of my education-y one as well, so happy to connect with teachers from everywhere. That's my dog as well, on the left. That's the hairy one on the right-hand side. So, thank you. Thank you very much.
Okay, thank you, Jim. So we have about 10 minutes for questions now. So raise your hand, I'll bring a mic to you.
Thank you, and thank you, Jim, for sharing all of that. Just with regards to the project that you mentioned with your assessment, just wondering what you used as a basis for that, and whether or not you extended with Python or Pygame further in that, or perhaps something else. And just also very quickly, I was interested when you said about for digital solutions and the use of JavaScript and or the Python for that. It seemed like you're obviously passionate about Python, and just wondering how come JavaScript is perhaps getting a little pushed in that respect. So those two questions, please.
Okay, well, I'll start with the second one first. Thank you very much, by the way. I wasn't expecting questions, so I'm a bit off guard. The JavaScript is pretty much me and my head of department. I'm kind of more Python, he's more JavaScript, and he's the boss. So short answer. But that said, he's not like no Python ever. It's more just, JavaScript, in his professional opinion, is a little bit more applicable in those sort of younger grades. I would debate that a little bit, but yeah. With regard to the projects, they're generally pretty standard HTML5, CSS, a little bit of JavaScript, web presence things with some capacity for Python, but with the sort of skill levels of our cohorts, introducing a fourth kind of language on top of HTML, CSS, and JavaScript could be problematic. But there is some room there, I believe, for that, but I need to research that myself a bit more. Yeah, so at the moment, it's pretty stock standard stuff, just HTML5, CSS, JavaScript. Yeah. Thank you.
Thank you. You mentioned that a lot of people migrated from Flash to HTML5. So why did you go with Pygame instead? How do you compare the HTML5 game frameworks with Pygame?
That's a good question. I haven't actually used a lot of the HTML5 frameworks myself, just a little bit. I've only dabbled. But I was keen, because I had that personal interest in Python, to actually just see if we could achieve the same things with Pygame earlier on. But yeah, beyond that, I think, yeah, a little bit hard to answer. It's just kind of a personal preference, I guess. Yeah, just sort of moving into the Python Pygame, seeing if we could do it. And I think we kind of can, but I need a little bit more time to sort of build up my chops in that regard. But I know that, yeah, we could do the same kind of things in HTML5 pretty easily, but I kind of like Python. So again, personal preference.
Hello, yes. You mentioned that there were actually two subject areas at the moment which are going to either amalgamate or collide or something soon. So what sorts of programming do they do in the other topic? And in particular, where is robotics in this?
Okay, in the digital solutions?
No, in what's taught at your school.
Okay, we typically do robotics in years 7 and 8. That's explicitly robotics, so that's Lego NXT. Doing Robot C at the moment as well with year 7s and year 8s. We are moving into the digital solutions syllabus has a fairly heavy component. The last time I checked, it's gone through a few revisions, but it does have machine learning in there, and it has got Arduino, IoT, all these kinds of things, which has a bit of space for robotics. But in ITS, it's not specifically or not explicitly included. So I suppose in IPT, which was the other subject, you might find that because they have to, as part of the IPT syllabus, they have to learn a language, which has been, in previous years, Visual Basic, it's been C, C#, it's been, something. So it's, we're trying to find this balance of feeding a little bit of that in, but attracting girls to the subject through the design and multimedia aspects as well. So trying to find that nice, healthy balance, but in a few years it will all be gone. So see how we go. Watch this space.
I've also had issues installing Pygame on Macs. One of the issues was the IDE that comes with Python idle is terrible, particularly on Mac. What did you use as the sort of coding environment for the students to develop in?
Idle.
I used idle on the Mac. Oh gosh. Okay. From
memory, I think that's all they use. I don't think any of them used anything else. I don't think. I could be wrong. But yeah, mostly the idle.
For installing, did you end up using Homebrew?
We used the wheel.
Okay.
I think we use homebrew. Some of them did homebrew, and some of them did some of the other methods, but we all got there in the end.
Okay.
Yeah.
We got time, or? Oh, sorry, we're out of time?
One more quick one?
Last
more.
question.
One more. My legs are getting tired.
What contact have you had with other secondary schools programs with teaching either Python or just more free software generally like JavaScript?
Oh, good question. Well, I have, I'm not sure of what Victoria does, but in senior assessment we have a moderation which is called, in year 11 it's monitoring and in year 12 it's called verification. And each district has a panel of teachers, and I'm on one of those panels. So I get to see other schools' work programs and get to see their assessment and sometimes borrow them. I mean, no, I look at them and I get inspired by them, and I don't steal them at all, no. So yeah, it's like I said at the start, lots of schools are doing different applications of the subject. They're doing different languages as well. A number of them are doing Python. Yeah, it's a little bit all over the place, to be honest, but in a good way. One school's even bringing in SQL into ITS, which is kind of unheard of because SQL is normally reserved for IPT. So yeah, but it's a fun time because we know the subject's on the way out, so we can kind of just do what we want, have a bit of a party. So yeah, and it's great getting that feedback from those other teachers in that panel situation as well because it's a good little panel. Yeah.
So we actually do have time for a couple more questions.
Oh, okay.
Clocks are hard.
I was not expecting so many questions.
Just trying to get a couple of fine details. So those projects took you 3 weeks. How much prior knowledge did the girls have come into that? Roughly how many hours per week did you have to spend on it? And did you provide any kind of structure in the program, or did they write everything literally from nothing?
Okay, so there's a few elements to that question. I'll try and answer as best as I can. With regards to Python, they'd only done a little bit of mucking around with it as sort of filler at the end of the term. Not filler, proper learning, right? It's Python. But after all the assessment had happened, I just went, okay, guys, let's play around with Python and make, a little... I stole the idea off Tim Stevens, who spoke here a few years ago. Just make a little wizard generator from Harry Potter. So you basically write a few lists, pick your house, pick your animal, pick your wand, and then just randomly generate a wizard. Bang. It's pretty cool. So just a few little muck around things like that. So this was the first task they did this year, which meant they'd had Christmas to forget everything I'd ever taught them. So any prior knowledge was kind of just, with Python, was pretty much at the base level, absolutely nothing. The structure I gave them, the scaffolding I gave them rather, was I would show them, let me just scroll back here, and I'll just see if I can bring up that shot of the code. So setting up like your constants, for example, just the convention code of making that capitals, the RGB, importing your modules. That is a video, but it's not playing. Setting up your variables, all this kind of thing. So I'd set up the core factors that they needed, just the basics of movement, keyboard movement, and collisions, and that was it. That's all I gave them. And as I said, so I used the Office 365 videos as well, so they could patch into those. And each one of these just says like drawing shapes, so how to actually just draw a basic rectangle or circle. And that's pretty much it. And I said, okay, you design your game, have a look at some different arcade styles and go with that. So that's why we had some that were sort of dropping things from the ceiling. Others were just a maze game. Yeah, so they kind of were able to bring in their own creativity from that basic scaffolding. Yeah. How much time? Oh, sorry. So it's in-class time. They were, let's say, for, I think, what was it? 5 hours a cycle. So, yeah. So 5 lessons per fortnight. So they did a little bit of pre-work as well. So in-class time, 5 lessons a fortnight. So, and then, yeah, they'd work on it at home as well because they were just so keen to sort of, it's only a small class, so they're all trying to, in a friendly way, try to get the edge on the other ones. So yeah, it wasn't a lot of time, but I think they did, for the time that they had, I think they did fairly well. Yeah.
You said that they got marked down if they hadn't done design or showed you design. Did you teach them any tool for designing?
Oh no, sorry, that's just a general comment on technology, just in general. It wasn't strictly speaking these guys. I said their documentation was kind of, it was okay. But I just mean in general, when I'm teaching Year 8 technology, for example, and I'll say, okay, make a game in Scratch or Game Maker or whatever it might be, they'll make it and then go, okay, where's your design document? Okay, oh, okay. No, but no, I definitely say, guys, you have to complete this design section, even to the point that we're including that as a draft. So that has to be due 2 weeks before the actual project is done, because it can be quite an issue. Not always, not always. Maybe I'm exaggerating, but.
Okay, that is time. So thank you again,
Marvelous.
Jim.
Thank you.
And we'll be back here in 10 minutes.
Beautiful.